So in this video, we're going to deal with the second part of this problem from the textbook, problem 3.36. So we already did the 3.35 where we were given specific gas mileage and we were asked to figure out what the percent of all vehicles had a better mileage than the target 28 miles per gallon. In this next part of the problem, we're actually going to look at going in the other direction. So for this one, we want to look at which vehicles or how high must the vehicle's gas mileage be in order to fall into the top 5% of all vehicles. So again, just looking at that problem, we can actually draw what it is we're looking for. So I'm just going to draw the normal curve because that still applies here. And we know from previous examples, we know that the mean is 22.2 miles per gallon. So I can, draw my mean right here. So mu is 22.2 miles per gallon. So that's a given. And I also know that the standard deviation is 5.2 miles per gallon. So up in the corner here, I like to write these down. It's just useful. So this is 5.2. It's just useful to kind of have them at hand and clearly written out. So the question here is what mileage does the vehicle's gas mileage have to fall in order to be in the top 5%? So the question that they're really asking when you look at the chart is what point in the chart, and I'm just going to randomly pick a point, what value does this need to be here in order to be in the top 5%? So this percent right here. So this is the, I'll just call this the top 5% right here. So, I'm just making a guesstimate as to where it might fall on the graph. Obviously, I don't know, but what I do know is what I've got written here. So now, we don't have a z-score. We don't have really the means to calculate the z-score because we don't know what the x is. So we don't know this guy here. So we can't figure out the z-score, but what we do know is that we have a chart that we can look at in order to derive, go in the backwards direction. So if I look at a chart, and I'm just going to bring a chart up here, and this is the chart from the back of the book. And if I look at this chart, I can go down and I can actually look for something that falls within 5%. But now the 5% is on the right side. This table only talks about the probabilities of things being on the left side. So we actually need to adjust our thinking a little bit because we're not looking for the top 5% right now. We're looking for the top 95% or the bottom 95%, and then we can figure out what that top 5% is. So this area here is the 95%. It's really just whatever's left over that's not in the top 5%. Remember, everything under the curve, the cumulative proportions have to equal 1 or 100%. So by making this assumption, we're still correctly making the assumption. So anyway, so now I need to look for something that's close to 95% in this table. And if I look at it, I know it's a little hard to see this, but I'm looking at the numbers themselves, the 0.9, 0.8, and so on and so forth. And so I see I'm getting closer if I'm like right around here, 0.9452. So I'm just going to keep going until I get to 9.95, but I don't go over 0.95. So this guy right here goes over 0.95. So it's this guy here that we want, the 9495. And that gives us a z value of, we can follow this back to this 1.6, and then we can follow it up to the 0.04, and what we get is z equals 1.64. So that is our z value for the 95%. Now you could try to get a little bit more precise with this calculation and actually take the average of these two. I believe you'd probably get something along the lines of 1.645 maybe. And so then you might want to round up to 1.65. But overall, so this is approximately, and this is also approximately using the average here. The average of the 0.9495 and the 0.9505, just because, you know, it's kind of like halfway between. So this is just a little bit more accurate than the, you know, just getting the first value below what your target value is. So, and if you were to do this in Excel, you would probably get a number closer to 1.645. So we're going to round this up. So we're going to say 1.65 is our z-score. Now, the z-score here is the z-score for the 95%. And we actually need to figure out what the value is. We need to derive the value now from the z-score. So z is 1.65, and we know that the formula for the z-score is x minus the mean over the standard deviation. If I want to go in the opposite direction to figure out what x is, I can rewrite this as x is the mean plus the z-score times the standard deviation. And this is multiplied. I can put them in parentheses so it's a little bit more obvious. So that's what we're targeting. So we don't know x. That's what this guy right here is. So x is equal to, well, we do know mu, 22.2, plus, and now we know the z, which is 1.65, times sigma, or the standard deviation, which is 5.2. And if you do the math on this, you should get somewhere around 30.754 miles per gallon. So that would mean that you would have to have mileage of, and I'm just going to delete or hide this just so we can have a little bit more clear of a screen here. But what we're saying here is that we would need to have a mileage of roughly 31 miles per gallon, and I'm rounding here based on this number, roughly 31 miles per gallon or better in order to fall in the top 5%. So I think the biggest thing to remember is the fact that we are always calculating on the left when we use these table in Appendix A. So you need to be careful not to assume that you're looking for the 5%. You have to actually do a little bit of recalculating in order to do it relative to the left side of that curve.